All right, so let's continue on with some systems. Going into our delta math. Again, you may have already been in there if you've been working on this section, watching the videos with me. So here we go, graphing linear inequalities. So this is really going to at first mirror a lot of what we did for the other section where we were graphing the system. We're looking for the slope and the intercept and all that. But there is another element with graphing inequalities. There's an element of shading, and I'll talk a little bit about that for just a moment. So the first thing we want to understand is that this is not really in the best graphing form as it sits currently. We really want only y by itself. So this negative x, I'm really wanting to add that x over to the other side. So I'm going to use my little pen here. Let's see if it'll let me, let's see, we had negative x plus y, and then we had a less than or equal to, what was that number, -7. And this was also or equal here. So let's take a moment to walk through a quick process where we get y completely by itself. Let's add x from one side to the other. And these are not like terms. They don't both have x, or they're not both constants like 7 and 6 without an x or another variable. And so I don't want to combine them. I'm just going to leave positive x minus 7. Some people may just say -7 plus x, but I want to graph it here in a moment, and I'm really looking for that slope-intercept form to be able to do that quickly. And so a lot of this is very similar to when you do an equal sign. A few things that you want to remember: if you ever divide by a negative across this while you're solving for a variable, the sign could change on you. That didn't happen in this one. And we also want to understand that you could either be using a solid line or a dashed line when you graph inequalities. It depends on if you have an or equal or not. If you have an or equal, you'll use a solid line, just like you have a solid line under this. And if you only have less than or only have greater than, well, 10 is not less than 10. Anytime it's the same number on both sides, it's not true. So that dashed line represents the fact that no point on the line really solves it. So let's go back. -7 is our y-intercept. So let's start at -7. And now I have a positive 1 in front of that x. That's our slope value. So I'm going to go up 1 and over 1 in both directions. And so now I don't want to change my line. I like the line that I have currently, but I may want to change the shading. And like I said, we want to either shade below the line or maybe above the line. It just depends. But for this one, we want to pay close attention to this. This is the word less than right here. And so I want to graph where it's on the lesser side. It's below the line. And I think the changed line actually means something else. I think changed, that really makes it dashed or solid. And so for this one, going back to what I was saying, because it's or equal, we do want a solid line here, but we want it shaded below that line. Okay. So let's go to another one, and let's see what we got in this case. Let me get this over in my software. So I want to write this on another piece of paper, and I'm modeling in my software here. But again, you're trying to get y completely alone in order to graph it easily. So I'm going to add x over to the other side, and this does not go together. They're not like terms. And so let's do 6y less than x minus 6. Again, because I want to not combine these, I'm just putting x from the left side of the inequality to the right side. And now I want to divide everything by 6 because I'm really wanting to get y by itself completely. And so because I'm dividing by a positive 6 here, that less than does not change. But this is now 1/6 x as my slope value. And then -6 divided by positive 6 is -1. So now when I go to graph it, I will pay attention to a few things. One, my y-intercept will be somewhere at the -1. I'll go up 1 and over 6 for another point, and then I want to dash that line. I'll also want to pay attention to it being less than that line based on that inequality. So let's execute that on the other page. So my y-intercept was -1. That slope was up 1 and over 6, and it should be a dashed line. And then I want to shade below the line because it was less than. Okay, so just to walk through that real quick one more time, when I solve for y, 1/6 starting at -1, so I went to -1, I went up 1/6, I wanted a dashed line because it's not or equal, and then at any point below that line will solve that inequality. All right, and then they're going to walk through that process for you, kind of explain the same thing that I explained. So I'm going to back up. Let's look at point solving systems of inequalities. And so basically what it's asking me to do is understand, just by looking at the values for x and y, like which of these values would go in for and make it true, which values go into the inequality for x, and it calculates something that is actually a true inequality statement. So let's take a picture of that and move that all over into my software for a moment so that we can kind of explore this. I don't think it lets me write on this particular screen, so that's why I got this. So now let's take a moment to kind of think about it. So this is my x value and this is my y value, and if it's a solution, it means it plugs in and it works perfectly, and it says which one would not be a solution. So really we're looking for one that fails to work in both of them. So right here, I've got my y value, -7. Is that greater than, plugging in 3, so -4 times 3, okay, that would be -12. And then let's add 4 to that. Final side here, that gives me -8. And is -7 greater than -8? And the answer is yes. In the negative world, -7 is closer to 0, so it is greater. So this particular point is a solution in the first one. Let's check to see how it works in the second one. -7, is that less than -2x times, or -2 times 3? That'd be -6. Let's add 8 to that, and that's the same as like 8 minus 6, giving me 2. And that's another true statement. -7 is less than 2. So because I want one that is not a solution, I don't think I want to pick this one. So let's think about it. -10 times -4, that'd be +40. And then if you add 4 to that, you're looking at getting 44. Now I think there's a problem here because -3, that's the y value, and there's no way that's greater than +44. So I think we have our culprit here. This value does not seem to work for one of the places. So once I've figured out one of them, I can say, ooh, that one doesn't work. It seems to work maybe in the other one, but not so much in that first one. So let's take another look at that. Immediately I notice this is or equal, so they could be the same on both sides, and that would be okay. So let's take a picture, let's bring it over, or get your sheet of paper and maybe do some mental math with pencil and paper, calculator, whatever you do to kind of plug these values in to really understand what you are looking at in terms of things that are true or false. So let's see, it didn't really snap in. There we go. All right, so now we're looking for the one that is not, and that could change on you. Just pay close attention to the directions. Starting with the first one, -2 minus 3 be -5. And if I put -4 over here, that would be greater than or equal to -5. That's true. Again, in the negative world, the smaller the number, it's really bigger. So let's try maybe on the other side. -, that'd be +2. And if you subtract 3, that'd be -1. Let's see if that comes out to be true when I put the y value in. -4 less than -1. So that works out to be true. Let's see, -8 in for x minus 3, that's -11, and it's wanting me to put -10 over here, and so that one is greater than -11. That's good. Negative, see, I've got a negative when you plug the -8 in for -x, that'd be +8. Let's subtract 3, that gives you 5. I'm supposed to plug -10 in over here, and again, that's true, -10 less than 5. So both of these are working so far. We're looking for the one that's not. So let's try, okay, 10 is your x. 10 minus 3, that'd be 7. -1. -1 is not greater than or equal to 7. So that one right here is really causing the inequality to not be true. And so it's not always, hopefully, that top right corner answer, but always just plug in the values and see which one you think works the best. Okay, maybe one more. Okay, 10 minus 8 would be 2, and 8 would be greater than 2. Let's try this one that it seems to be doing all the time. 6 minus 8 is negative 2. Ooh, it's got negative 7 over there. That's not greater. So looks like a common answer there in the top right corner. Maybe that's not always the case. Let's see, is it here? The 2. Negative 3 times negative 4 would be 12. Minus 4 would be 8. Ooh, 7. Again, that one's failing. So hopefully they're not, I must have been doing some quick mental math there and made a little mistake. So hopefully you will try each point and you won't do what I just did. You start getting points off or you start getting frustrated. Take time to plug the numbers in, take your time, check your work, and you will be fine. Let's look at one more where you're doing systems linearly. So it's the same idea. You're graphing more than one line and you're looking to shade above or below each line. You're also looking to see if it's dashed or solid. So let's see what this first one's got. So we're going to use that slope intercept form starting at 2, down 1, right 1, and I think this should be a dashed line because we're only talking about greater than, not or equal. And we want to shade greater than. Y is greater than this line. So I want to shade where it's above it. Here's below it. Here's above it. Below it, above it. So greater than is what we're going for. This one, we're starting at negative 4. I'm going up 1, right 2. That's the slope here. Again, I want this to be a dashed line. And for this one, you want less than. So we got the lower end down here. And so it's saying a point. Let's read the directions kind of just a point. Was that state the coordinates of a point in the solution set. So it's just any point. So I see 9, negative 1 or 9, negative 2. Any of those points seem to work. So you could have picked 8, negative 4 or 6, negative 2 or 10, 0. Any point that's in this overlapping region will be an answer to your problem. Okay, so let's try one more in that section. Didn't mean to back out completely. This one's dashed line, and then we have a solid line. So let's do the dashed line. So starting at 4, there's a 1 in front of this x that's invisible. So it's rise 1 and run 1. And see, that's the idea that, like, for example, x could be 4. Well, 4 plus 4, follow that all the way up here, and so you're going to get 8. Because 4 plus 4 is 8, or 5 plus 4 is 9. So that's why you just want to go up 1 over 1. That's the rate of change. So dashed line and less than for this one, shading below the line. And now let's graph starting at the second line's y-intercept. Looks like it goes to 1. Negative 1 over 2, down 1, right 2. And this will be a solid line because we have permission for it to be or equal to both sides. So any point on the line is a solution. And let's just make sure we got our shading. So that'd be greater than. This would be less than. We want less than or equal. So anything below this seems to be a solution. So we want to look for an overlapping region, which is basically down in here. It's less than both lines. So I'm going to pick the point negative 7. Let's see, that's 0, negative 7. And then I'm going to submit my answer to check it. Alright, so congratulations. You watched all my videos to help you get through all of these sections. Hopefully you have pushed yourself as far as you can in each of these to 100. I obviously didn't do all of them because that would be just a ton of video time. But if you are stuck in any section, please contact me and I'll be happy to push you over. I'm going to be using these grades to replace any coursework grade from earlier in the semester, and so really looking forward to doing that with you. And also, next video will be all Edulastic, getting you set up with an Edulastic account, getting you doing the assessment. I may even do a little bit of an example of how it works. So look forward to that tomorrow, and you can take that Friday, Saturday, Sunday, or Monday. So there's a 4-day window for you to be taking that. Contact me with any questions. I'll be sending information out about that through Canvas and also through emails, so be on the lookout. Contact me with any questions, and look forward to talking with you. Thank you so much, and you should congratulate yourself. Great progress.